Am I audible? Akash, am I audible?
Yes, sir, audible.
Okay. So I hope you don't have any other class now. This is my class. So let's wait for 2 minutes for everyone to join. Yeah. So we will start right now. So please give me a feedback whether I am audible and connected right now. Abhijit, am I audible? Abhijit, am I audible? Subrad, am I audible? Please give me a reply.
Yes, sir.
Yeah, thank you. So, okay, okay, we are ready now. Okay, so in the previous class, we were discussing about how we can change the rotation of a motor by using contactors, right? So we had already discussed that. Now we will see how we can do it with the help of a contactor in the field side. So this is the field side. Okay, so this is the field side, right? So if this is the field side, we need to change the direction of current through the field, right? So in that way, we can again change it. So going to a fresh screen. So say if this is your armature A double A, then the screen, then if you have this in field, say F double F, and if you use here positive and negative, then what will happen? The current will flow through this direction, and the motor direction will be say somewhat in the clockwise, right? just for assumption, right? Now, if you just reverse this, you change this plus to negative and you change this minus to positive, then what will happen? The the direction of motor will actually reverse, right? But what is the thing that it will take much more time? Why? Because the value of L here will be much more higher with respect to the value of L that was in the armature. Don't you think so? That the time constant over here will be higher than that of armature. So reversing the motor's direction in this case will be much more time taking, right? So when we can afford time, then it's okay. If we want to reverse the motor very quickly, then this field type of reversal is not preferred, right? Then we will see that a single phase DC drive will see how many types can it be. First of all, it will be single phase half wave converter drive that we have done in the ED lab. Then we have also, some people have also done this semi converter drive in the ED lab also. Then the next will be full converter drive that we'll see, and then finally we will have this dual converter drive. So one by one, let us see. So this is the uh, how many of you have already done this experiment? Just give me a reply. Anyone did this experiment?
Yes, sir.
Yeah. So what was the thing? We were actually in the lab. What we did, we just connected this field to this part as a shunt motor, right? So we did not use this. But in case of a separately excited motor, we could have used another type of uncontrolled rectifier and just give it the full amount of voltage to this, right? So in the waveforms, what will come? If this is the thyristor, this is the thyristor SCR, then if you fire it, what will come? This types of waveform is for the current one, and for the voltages, I'm just trying it out, testing out it out here. So this is the omega t. This is the input waveform. Then what will happen if I cut it out here approximately, and this is the back EMF at a certain speed. Then if I cut it out here, if I fire it here, what will happen? It will come out like this. And after this point, where back EMF is equals to the input voltage instantaneous, then some amount of downside it will go, and then again it will be flat, right? So this would be the output voltage. Is it not so? And in the next cycle, this thing will again come. Although all the people who have done the ED lab have seen this waveform with their own eyes, right? In the DSO. Okay. So how much it will dip down, this will depend upon the value of L, that is the inductance of the armature. Right? So what is the average value of this thing? It is V average is equals to Vm by 2 pi 1 plus cos of alpha, right? I hope everyone knows this equation, how to find it out. Should I show it again? Okay, I'm showing it one thing. So it will go like this. So it will be the value here. The value of back EMF is not considered here, so that's why the average voltage is a bit different in that place. So it is going say like this. So you have to calculate the V naught average is equals to 1 upon 2 pi integral from 0 to alpha, that will be E d omega t at a certain speed, plus alpha to 2 pi, sorry, alpha to pi, not 2 pi, alpha to pi Vm sine omega t d omega t, again from pi to 2 pi, it will be a flat E d omega t. So is it good? Did you understand it? So 0 to alpha, it will be a flat one, that is E, that is the E back EMF. And then from alpha to pi, it will be Vm sine omega t. And then from pi to 2 pi will be somewhere here. It will be a flat one, E back only. So did you get this thing? So, but this is actually a half wave control rectifier, so it has much more ripple factor, right? So it is not used for large motors. It is only used for small motors up to 500 watts. Why? Because this thing is very simple. It requires only one circuitry, and because there is a L type of load here, so we attach a freewheeling diode also. This is AFWT, right? So freewheeling diode also helps to increase the power factor. So it will freewheel the current through the diode. And then we come to this one as usual. So this is the output waveform which I was discussing out. So this is the input waveform. This is the firing angle, and this is the back EMF section which has to be there, that E back, right? And then finally we have the current. So when will the current be going through that? It will fire at this point, so the current will start to increase. At this 0 point, the current will be maximum, and then at this point it will go down, right? So this is the current waveform. That is the current waveform through the armature current. This is it. And so that will be the average one. So what about semi-converter? How many people did the semi-converter experiment? Semi-converter experiment? Anyone did the semi-converter experiment? I think Puran did it. That whole batch did that experiment. Guys, kindly reply. How many did that experiment? Priyambada also did it, I think. Anup, did you did it? Did you do it? Avnish has been absent for quite a long time. Okay, so this is the which one? Symmetrical or asymmetrical? Abhijit, are you there? Can you tell me whether it is symmetrical or asymmetrical? As I'm connected or not, I'm finding it very hard to detect. Yeah, there is some chance symmetrical. Yes. Yeah, it is symmetrical. Good. Uh, just a second. Let me draw it out. So, if I make a converter like this, then it would be uncontrolled, right? Now, what if I do one thyristor here and one thyristor here? It will become symmetrical one, and I have to attach a brushes there, then R, L, E. Sorry for that mistake. It happens. Now you have to freewheel the diode, so there is no freewheeling diode path here, as this is the symmetrical one, because the left side of this line is equal to the right side of this line. So it is a symmetrical one, and so you have to attach an extra freewheeling diode. So this increases the cost also, right? But this won't have the negative peak now. So this is the symmetrical AC to DC full wave converter, right? This is semi-controlled, symmetrical semi-controlled AC to DC full wave rectifier. So this is used up to 15 kilowatt of the power. Why? Because say you are actually saving the cost of two thyristors, right? So here is only diodes, it is not thyristor, so you are saving the costs. and the output voltage of this is Vm by pi 1 plus cos alpha. Alpha is that firing angle. So this will be the output and the armature current, and finally you have the voltages for the input and output. So this is the input voltage, this is the output voltage, and here you have to again consider the speed of the motor. Here it is given at 0 speed, but that will not be the so. What will happen? Okay, when you go to screen, what will happen if the motor is running at say speed which is greater than 0? So if it is like this, then if it is like this is the E back EMF at a certain speed. You must remember that the back EMF is a function of the speed itself, k phi n, right? So if the speed increases, then back EMF will also increase, or if it decreases, it will also decrease. So it is for a given speed. So then this will be the, or this will be the minimum firing angle, alpha minimum. Then after this will start to fire, and at this point it will go to 0. It might go a bit lower also depending upon the value of beta or the inductance, then it will again repeat the same thing. So this will be the output voltage waveform. When will the current flow through it? The current will flow through it as soon as the V input is greater than back EMF. So these are the points where it is greater, right? It will go like this and it will come back. So it will be maximum at the point of this. At this point, it will be the maximum value and then it will again decrease. So when it is decreasing, there is no negative part. Why? Because the freewheeling diode, this is the diode FWD. This is actually conducting that negative part of the voltage waveform, right? So any doubt on this? Please come up with the doubts for this part. Okay. Then, so this is the asymmetrical part. I know some people are doing some mistakes. Let me pinpoint them out. Some people are making the semi-converter bridge in a special type, which is not the thing. So some people are doing what? They are attaching one thyristor here and one thyristor here. So this is thyristor, and again this is the thyristor, and this is diode, and this is diode. So is this configuration okay for a semi-controlled one? Is this combination okay? You can give it in the chat box. Is it okay? Let me go to the paint screen. That will be better. Just see your errors. Okay. Just a second. Yeah. Right. So some people are doing what? This is a diode. Sorry. So this is a rectifier one, and some people are attaching one thyristor here and one thyristor here. So this one will be T1, T2, and this may be T1 and T2, and they are attaching it to the AC supply over this point. So tell me, I want to hear that is it correct or not? If it is not correct, why it is not correct? Shiv Kumar, why is it not correct? Just pinpoint that thing. You can actually speak up. Abhijit, why is it correct?
Sir, thyristor must be connected in position to D2.
No, that's that you are comparing with the standard circuit and tell me what would be the problem if I'm doing this sort of thing. What would be the problem? Just think about it. What would be the problem? Any idea? Abhijit, why is it correct? See if this is the input waveform. Yes, Abhijit, why is it correct? Tell me. Okay. So in case of the positive part of the waveform, if this is positive and this is negative, what will happen? T1 and T2 will become forward biased, right? And if I fire them, they will start to conduct. So T1 and T2, right? So if say if I'm starting to make them conduct over here, so it will conduct up to this point, right? I'm not considering the back EMF right now. I'm just considering the waveform at rest. Now when this will be reverse biased, say this one is negative and this one is positive, which are the reverses that will conduct now during the negative half cycle?
D1, D2.
Yes, D1 and D2. So if D1, D2, so both are diodes, so can you control them?
No, sir.
So output waveform will be simple like
Understand.
this, right? So this one D1, D2 and this one will T1, T2, right? So you see it only in one part of the waveform you can control it, right? And in the other part you cannot control it. So the waveform will be like this. Do you want this kind of waveform where half part is controlled and the other half is not? No, no. So what do you want? At least out of these combinations, it must be like T1 and at least one thyristor and one diode must be there, right? So that in the line, at least the thyristor, through the thyristor, you can control the current flow. Is it not so? Do you understand the difference between them? So at least what we need at least T1 and say one diode, and again here one thyristor, one diode. So in each path of the current, there must be at least one thyristor and one diode. At least one thyristor if you want to control it. Right? So at least one thyristor. So that's it. So this is the not the correct one. Okay. Let me come back to the yeah. Yes. So this was single phase semi converter. Yes. So this is single phase semi converter drive. So this one is the asymmetrical one. However, this has a freewheeling diode. Can you see this D1 and D2? This is will act as a series combination of two freewheeling diodes. That means it is becoming a freewheeling diode. So this means this will have no negative part, right? So asymmetrical does not have any negative part. And then say actually we have some boundary conditions. So discontinuous modes is up to this, and then this is the boundary between the continuous and discontinuous modes of operation. So here one important point is given for additional information. There is a closed loop control system. If you are developing response in discontinuous mode is actually more oscillatory. So people actually want a continuous mode of conduction as a continuous mode. Okay, so single phase full converter drive. So we were waiting for this. This will be rated for a higher power, say up to 15 kilowatts or more. Right. So what is the specialty? That it has all four are the thyristors. Here all four are thyristors. Nothing is diode here. No device is only uncontrolled here. Every device is controlled. So what can you have? You can have both the quadrant of operation. You can go for negative, uh, the negative values of the voltages also are all possible. And here is the field side. So this is the field side and this is the armature side. So in the field side, if you want to control the field using a full control thyristor bridge, then also it is good enough. And if you want to go for armature control only, then you have to use 4 thyristors. So which one is preferred at, say, the speed of this machine is rated at 1500 RPM, and I want to control it from 500 to 1000 RPM. So which technique should I go for? Should I go for field side or the armature side control? Any idea? Yeah, I need a response here.
Armature side.
Why armature? You have to have a reason. You can also give it in the chat box if you are, if you want. You can give it in the chat box also the answers. Tell me which side you should go for, armature side or the field side. So why no answers? Everyone is sleeping after taking lunch. Huh? Yeah, wake up, wake up. So armature. So why armature? Because this is a speed which is lower than the rated speed. So you should go for the armature side. In case I wanted to have a speed control in the range of 2000 to 3000 RPM, then I would definitely go for the field side, right? So in that case, I would use these set of diodes, these set of thyristors instead of the left sides, right? So what would be the waveform? Waveform would be this, as simple as that. So what is the output of this thing? 2 Vm by pi cos alpha. As you everyone know from power electronics section, it will be the average voltage will be 2 Vm by pi cos alpha. This is irrespective of the back EMF, right? So what will be the control range when alpha is 0 and alpha is pi? What would be the control range? Okay, let me show you. So the control range will be, so that output is equals to 2 Vm by pi cos of alpha. So alpha when it is 0 to 0, then V naught is equals to 2 Vm by pi, right? It will be the maximum. So this will be 2 Vm by pi, this point. And then when alpha is equals to 90 degrees, V naught will be, cos 90 is 0, right? So V naught will be 0. So it will straight away go from here to this point, and then when alpha equals to 180 degree, what will be it? V naught equals to minus 2 Vm by pi, as cos of 180 degrees minus 1. So it will go like this. This would be the range. Minus 2 Vm by pi to 2 Vm by pi. So this will be the range of operation. Okay, so single phase full converter. So this is the discontinuous conduction mode. So when is it called discontinuous actually? When is it called discontinuous? Okay, let me show you. The point. Yeah. So why is it, when is it called discontinuous? First of all, if I have a waveform, and it is like this. Now, if I have the output waveform, this is the input waveform. If I have the output waveform, say I'm starting out from this point, see if I am having this waveform, and after some time it is going decreasing, and at this point only, at say point A only, the next waveform is starting. Then is there any break here? Is there any break where none of the devices are conducting? Is there any point here at this time when none of the devices are conducting? What happened today? No one is giving any response. Everyone went to sleep or what? I know it's after lunchtime, so it will be a bit tough, right? Plus, but please concentrate in the class. So if there is a time when none of the devices are conducting, then we would have called that as discontinuous mode of conduction. Discontinuous mode of conduction. Yes, some chats are appearing. If a conduction is none of the devices will conduct. Yes, perfect. But if there is a time when all the devices are conducting, that means the moment beta is ending, at that same moment it is getting fired. So what will be the angle? In that, beta will be equals to actually alpha, right? If I consider this as beta, then this will be the only value of what? Alpha, right? Some people say actually pi plus beta is equals to alpha. In that case, they are considering, sorry, beta goes to pi plus alpha, right? In that case, they are considering beta from the very beginning to the ending of this. So in this case, beta will be equals to pi plus of alpha. This is not the thing. It will be beta equal to pi plus alpha. So it will all depend upon the notification actually. What are you considering as beta? In this case, in my case, this small angle is equals to alpha. So that's why beta equal to alpha in this case will give you a continuous angle, continuous conduction. Just a second, yes. Yeah. So yeah. So this will be the value of the input voltage. This is the output current. So see here you have a time where no current is there. So it is a discontinuous one. Again, it is having a back EMF section. It is going up and it is again moving up. Then this is the back EMF part. Right? And then this is the signal one. That is the source current. This would be the waveforms for discontinuous mode. So speed torque characteristics, the equation is given here. So this is the boundary between the continuous and the discontinuous mode of operation. Okay. Yeah. So this is what is called, this is for 2 Vm by pi cos of alpha. Right. So alpha will range from 0 degree to 90, 90 to 180 degrees. The two-quadrant operation can only be realized with overhauling loads which can drive the motor in reverse direction. That means what? It's a type of gravity-based load. That means the uh, that that load has the power to drive the motor by itself. For example, you have a flat road and you have a vehicle. So in a flat road, can the vehicle move on its own? In a flat road, if you are driving it and you are say giving alpha equals to 90 degree for 2 Vm by pi cos alpha, V naught equals to 2 Vm by pi cos alpha, alpha equals to 90 degree. So what will be the output voltage? Output voltage will be zero, right? So at this point of time, can it move by itself? If it's a flat road, yeah, need some answers. Abhijit, are you there? Anyone else?
Yes, sir.
So can it move on its own in a flat road if you are not
No,
giving it
sir.
wood? So, but if the road is a bit of inclined one, then if the road is inclined one, then it can move due to
Yeah.
gravity, right?
Yes, sir.
This so the load has the capability to make the motor move, right? So in that case only you can go for regenerative braking, right? You cannot go for regenerative braking on such conditions where it cannot move, right? So that is why for overhauling loads only, it you can go for the second quadrant of operation. So, so in which direction will the power flow? So this is for alpha less than 90 degree, this one diagram. So this diagram is for alpha less than 90 degree, whereas the current is flowing to the motor and the value of uh, back EMF is in the same polarity as that of the armature voltage. But in case of uh, this alpha greater than 90 degree, the value of voltage is negative. So voltage into current goes less than zero. So negative voltage into positive current will give you less than zero. And this is positive voltage into positive current will give you power greater than zero. That is, it will flow from source to the load. And here the power will flow in the reverse direction. Although the value of current is going into the motor. So for four quadrant operation, what to do? What to do for four quadrant operation? Just a second. So if you have this type of thing, this all these will be thyristors. Then for this type of load, what you will see, what you will see is you can control the speed of the motor in only one direction, right? And you can go for 2 Vm by pi cos alpha equals to V naught. You can go in only two directions where the reversal of, say, this is the V naught, this is the I naught. So I naught will be in one direction only, but V naught can change its direction, right? So it can have only two quadrants of operation. But what if I want to go in for the same characteristics in the reverse side? What will I do then? I want to go for it in the reverse side also. What to do? Any idea? Yeah, I'm showing you one option. Can we not reverse these terminals? Can we do it? This is say point A, this is say point B. Can I do it like this? Can I do it like this? I want to have the speed control in the reverse direction also.
Sir, but how will we do it? Like, is
You
it a
just,
fixed connection or?
yeah, if it's a fixed connection, then it will not be happening. If it's not fixed, so we have to add some contactors, then only it is possible, right? But these are mechanical things. So if you are always
Yes, sir.
changing this thing mechanically, what will happen? There will be carbon deposits in those contactors, and slowly it will decay with time. So this method is preferable where a budget is fixed and the companies don't want additional additional expenses. So what the other side is that, keep it fixed like this and have one converter reversed, the same converter added onto the next side of the motor, but in a reverse direction. So don't you think this will also work? Say this is converter P
Yes,
side
sir.
and this is converter N side. So P is standing for positive group, N is standing for negative group. So in this part, what will happen for alpha less than 90 degree? Say for alpha N less than 90 degree, where will be the positive coming? On A or point B? Alpha, alpha less than 90 degrees. So it will produce a positive voltage, right? But positive voltage with respect to what? Positive voltage with respect to this point, its own point, its own DC bus, right? So this will be the positive point, and this will be the negative point for alpha less than 90 degree. Now for say alpha greater than 90 degree, what will happen? It will produce a negative voltage, but negative with respect to what? With respect to its own DC bus. So it will produce a voltage positive on the upper side and a negative on the lower side, right? Do you understand this?
No, sir. Can you do it again once again,
Just a
please?
second. Just a second. So, I will be drawing it out again. Better way. Say these are all thyristors, right? And just keep on replying me at every instant. So,
Yes, sir.
what I do is for alpha less than 90 degree, which one will be the positive? Point A or point B?
Mm, Sir, point A.
Point A will be positive, right? Now for alpha
Yes.
greater than 90 degree,
Point B.
so in this point A is positive and this alpha greater than 90 degree, A is negative, right? So just look at this point in a reverse way. Just take 1 second, rotate it, flip vertical. So can you just see it now? What will happen now? If I've just flipped the circuit, now tell me, the things will be the same, right?
Yes, sir.
Things will be the same, but what I did, I just reversed
Yes, sir.
it. So earlier it was this, right? So what I will do, I will draw another circuit of the same thing, this time with a different color, say with the uh, say the red color. I will draw it on the right side, right? So this is very interesting. So I'm doing the same thing in the reversed way. So this one will be the, so these are all thyristors and this is connected to the same AC source. Now say this is point A, this is point B. So this, I will consider this point A dash and point B dash, right? And the green one will be point A and point B. So I will connect the motor in between, say, where is the motor? Say your motor is red colored motor. This is the motor and I'm connecting it to the positive and terminals. So I've connected it, right? These are the brushes. So now tell me, so this will be alpha 1 waste and this will be alpha 2 waste, right? Now the main difference comes out. So for alpha 1, if it is less than 90 degree, what about A? A will be
Positive.
positive, B will be negative. Now
Negative.
say I am switching off the converter one, right, which is the brown one, and I'm running only the red converter. So for red converter we have alpha 2. Alpha 2 is less than 90 degree, then A dash will be so for alpha 2 less than 90 degree,
Negative.
where will be the positive?
Negative.
The positive will be on the B dash
Negative.
side, right? A dash will be
Yes, sir.
negative, right? And for alpha 2, which is greater than 90 degree, what will happen? Alpha 2 greater than 90 degree, which one will be positive? A dash will be, A dash will be
Positive.
positive and B dash will be negative, right? So here there are two kinds of operation. One is either you switch on one of the converters and switch off the other one, or you run both of them simultaneously. I will tell you when each one is used. First case, when you are only turning on one converter at a time, so that either the brown one is turned on or the red one is turned on. So it is only brown one is, say brown converter is turned on or the red colored converter is turned on. So in that case, you can control the speeds individually, right? So can there be any case where both the converters are turned on? Can there be any case? Say, let's suppose a new fresher has joined and he doesn't know how to do all the things. So what he does, he turns on both the converters and just a second, let me clear out. He turns on both the converters and he puts alpha 1 at less than 90 degree and alpha 2 at less than 90 degree. Now tell me what will happen. So this green one will be
Motor
positive
will
here.
not rotate.
This one will be green one will be positive, and whatever the red one will be positive here and negative here,
Yes, sir.
right? So say this is 200 volts. Say each one is at a 200 volts. So 200 volts here and 200 volts here. So what will happen? So don't you
No
think it will
potential
be
difference.
an no? Think about it. This is positive, right? This is positive. Just have the KVL rule. Have the KVL rule. What will happen? This is positive here, this is negative here, and this is again positive here, this is negative here. What will happen to the two converters? Each one will be trying to flow a current through the other one. Don't you think so? So there will be a circulating current within the two converters. Is it not so? It's just like having two batteries in in this
Opposite.
in this fashion, right? Is it not so?
Yes, sir.
So what will happen?
Sir, but here it
The
is
two
batteries are
converters,
in.
the two converters will actually get destroyed. Is it not so? Are you understanding? If I am making two batteries like this positive one here and the negative one is here, see, this one is positive here, negative here. So this is being represented by battery V1, and the other one is representing that red one. Is it not like this? If two batteries are now connected like this and a motor is connected in between, first of all, think about these two batteries. They will have a circulating current here. Each battery will try to short circuit the other. Is it not so? So how
Yes,
much will
sir.
be the voltage? 200 plus 200, 400 volts. What is the resistance in series? Is there any resistance in series which will actually limit the current? No, it will be very, very less. It will be
No.
just the resistance of the connecting wires only, right? So what will happen? The whole thing will burst out. If there is an MCB, it will get tripped. If there is a fuse, it will get bursted out. So that would be the result, right? So this condition is not possible, right? So alpha 1 say it is less than 90 degree and alpha 2 say it is greater than 90 degree. So is it possible? So in that case, which one will be positive on the green side? Alpha 1 is less than 90 degree, then this one will be the positive, A will be positive, right? Right? And say this one is and this one is alpha 2 is greater than 90 degree, then what? The converter will operate with negative voltage for the red one. So which one will be positive, A dash or B dash? Which one will be positive, A dash or B dash?
B dash.
B dash will be positive. So listen first. It is running at alpha greater than 90 degree. So what will happen? 2 Vm by pi cos alpha. Alpha is greater than 90 degrees. So the voltage will be negative voltage. As cos greater than 90 degrees is minus, is negative, right? So what will happen? Which
A
one will be
positive.
positive and which one
A
negative?
A positive.
So
Is that correct?
A dash will be positive now
Yes.
and B dash will be negative. And if both voltages are 200 volts, then don't you think this is a stable one? It will not short circuit.
Yes.
Yes. So, but there will be, but because of there will be slight differences, right? Say this is 200 volts, this is 202 volts. It might happen, right?
Mm.
So we must add some kind of reactance in between, right? So this is called another mode. This is called the circulating current mode, right? So a small amount of voltage difference will persist, say 200 volts versus 202 volts. Due to these 2 volts, a huge amount of current will tend to flow, but because of the resistance in series, is the impedance in series, that is the reactor, right? Because of this reactor, what will happen? Thus, currents will be very less. But what is the advantage? That I am getting current from both the converters,
Yes.
right? And both the converters can supply more current. Say this is rated at 5 ampere and this is also rated at 5 ampere. So what will happen? I can draw 10 ampere from it.
Yes.
So in that case, what is happening? I will make this configuration for getting higher higher powers of motor ratings. So do you get this point? So using two converters, I am getting much more power. Is it not good that I don't have to design a single converter with a very high power rating? I can include two converters, and whenever the need for greater power arises, I can operate both of the converters in parallel, right? And in the sense, I can get more power, right? So this one has an equation to it, right? So what equation does it have? Can anyone tell? Because it was done in power electronics. So what will be the equation on the left hand side? 2 Vm by pi cos alpha, right? And what will be the equation here? The red one, the same equation,
2 Vm pi upon cos into cos.
right? So both
Yes.
of them has to be same. So this one say cos alpha 1, this is cos alpha 2. So if both of them has to be same, so 2 Vm by pi cos alpha 1 has to be equals to 2 Vm by pi cos alpha 2. So
Yeah.
because they are getting currents from the same AC source, so the value of Vm will be the same,
Mm.
right? So
Right.
But thing is that this is negative, na? This is negative. The magnitude is the same, but this is the negative. The magnitude has to be same, but this voltage is actually a negative voltage, na?
Yes.
Output. So 2 Vm by pi cos alpha 1 should be equals to minus 2 Vm by pi cos alpha 2. Is it okay? So in the
Yes.
sense cos alpha 1 must be equals to minus of cos alpha 2.
Mm.
So this one will be cos alpha 1 plus cos alpha 2 is equals to 0. So if you calculate it, if you use some trigonometric functions, and then you will arrive to this point, alpha 1 plus alpha 2 is equals to 180 degree. I leave the derivation to you. If you are not able to do it, just ping me up. I will supply you with the derivation. Right. So this one is the condition for driving this dual converter in circulating current mode. So alpha 1, that is the alpha of 1, and the alpha of 2, the firing angles, must be complementary. So if alpha 1 equals to 70 degree, what should be the value of alpha 2?
110. 110.
110. So that is greater than 90 degree. You can see it also. So this is the condition that has to be maintained for this thing, right? So it's okay now.
Yes,
Any
sir.
problem? Deep, any problem? Anyone else having any other problem?
Sir, in the first case where alpha was for both alpha 1 and alpha 2 was greater than 90, sorry, less than 90.
Yes.
In that case, sir, the batteries were connected
In
in
anti-parallel.
from positive,
It was
were
like in
anti-parallel.
anti-parallel.
So
Yes.
current would
It
so
wouldn't
current
enter.
will
It
flow
wouldn't.
from one to
It wouldn't enter the motor. It will straight away go to the what? It will straight away go to the next converter, and it will burst out. It will destroy itself. Just think of it. This is positive here, and here also, and here it is negative. So what will happen? A dash is negative. What will happen? Tell me. A dash is negative. What will happen?
There will be short circuit.
The battery, it will feel like the alpha 1 battery is positive here, and the alpha 2 battery is positive here.
Okay.
Is it not this type of configuration?
Mm.
So it will, and the motor is in between. Don't you think this is the thing like this analogically,
Yes.
right? So
yes, sir.
it will just short circuit.
Yes, sir.
It will just short
And burst
circuit.
it. Motor will burst it.
Motor will not burst. Any one of the converters will burst out. The one which will burst out will actually save, and then the motor will start to rotate. No? Right. So this is not possible, right? So what you have to do, you have to connect the two converters in such a way that the positive voltage is above or in the same direction. So this is
On
possible
the
now.
same side.
So is this possible? This is possible, right? So you can draw both the
Yes,
currents
sir.
and run this motor.
Yes.
So you can have more power, right? So this is the thing which we discuss, and for this the condition is alpha 1 plus alpha 2 should be equals to what?
180 degree.
180.
Complementary. We call this thing as complementary angles. So and tell me what is supplementary angles? If alpha 1 plus alpha 2 was equals to 90 degree, was equals to 90 degree, then we would have called it supplementary. It is
Supplementary angle.
complementary. So it is 180 degree. So they are complementary. I hope I wrote the spelling properly. Complementary angles, right? You must remember this thing. So let's have a quick verification of this thing. Let's have a quick verification of this thing, right? So say alpha 1 is
Sir,
30 degree. So what will
sir,
be alpha 2?
hello.
Yes.
Sir, can you hear me, sir?
Yes.
Sir, can you hear me, sir?
Yes, yes, yes.
Sir,
Tell
I'm
me.
telling that when alpha is greater than 90, alpha is greater than 90, then how the direction is reversing? Sir, can you explain that part?
That was in power electrons, no?
Alpha is greater than
So
90 when
Vm by pi
when alpha
cos
is
alpha equals to V naught. Just put.
yes, sir, but actually,
Yeah, I'm just going for that only. Just wait. Just wait. I'm going for that only. So just calculate out the values for V RMS equals to 230 volts. 230 volts AC. Just find out the values for alpha 1, alpha 2, and the values say alpha 1 is 30 degree. So alpha 2 will be how much? Tell me, how much will it be alpha 2? Alpha 2 will be how much?
150. 150.
So I'm compressing it here. So alpha 2 will be 180 minus 30 degree. That will be
150.
what? 150 degree. So let's put the value of 2 Vm by pi cos alpha 1. So this is the output voltage of converter 1, right? So what is it? 2 Vm will be 230 volts into 230 volts into how much? Root 2, huh?
root 2.
Root 2 by pi cos alpha 1, that is 30 degree. How much is it? Just find it out.
1 by 2, 1 by 2.
230 into 2 into root 2 divided by pi cos 30 degree. Abhijit, can you just tell me how much is it? Or
Yes,
anyone
So
sir.
else?
root 3 by 2.
Oh, what is the total value?
Okay, okay.
2 root 2 into 230 by pi into cos 30 degree. So for the converted to, we have 2 by pi
Sir,
230 into root 2 into cos of that
sir,
is
179 point something. 179.33.
yeah, 129 point
179, sir. 129. 179. 79.
179.
Yes, sir. 0.33.
You can just consider this 0.33, 179.33. What about the green one? This one is from the output of the converter 2. So that is minus 2 Vm by pi cos alpha 2. Alpha 2 is here 180 minus 30, that is 150 degrees, 150 degree, right?
So
So
that is
how
just
much?
minus of 1. Minus of 129.
Hmm?
Minus of 129.33.
One? No, no, just calculate it out. No?
Yes, sir. We have
How
calculated, sir. It is minus 139.33. It came out to
minus 1?
minus 139.33. That's the point value.
Both values are coming different.
No,
Yes,
sir.
sir.
That's modifying. Sir, just
Opposite
negative.
direction. Opposite.
Opposite
Opposite
sign.
and equal.
Yes, sir.
So that will be minus 179.33 volt, right?
Yeah. Yeah.
So I have this output of the converter. Here the output of the converter is 179.33, and another converter which is placed like this, its voltage is here it is positive and here it is negative,
Okay.
right? So it is 179.33 degrees, that is minus 1, right? Actually, this side should be the positive and this should be the negative, right? So do you get the thing? So now if you have
Yes,
the
sir.
motor in between, it won't get busted out. It will take in power from both the sides, both the converters. So you have already now verified the fact that alpha 1 plus alpha 2 should be equal to 180 degree. If there was a difference, say well, this is 179 and this is say might be 299, then what would be the thing? Then the problem would be one side of the converter would try to push the current to the other side of the converter.
Yes.
Right? So in that
Yes,
sense
sir.
also a huge current would have developed and would have destroyed, right? So that was the thing. 6.
Sir,
Yes.
sir, when you are saying that destroyed, like, I mean, how much current should pass to destroy a power converter?
That would depend upon the rating of the devices and the how much current would be there, how much internal resistance would be there in the converter side. So basically, it would get destroyed if it would pass some several amps, at 10-15 amps, or so the thing is that it will all depend upon the.
Sir, I mean, these are controlled rectifiers, right, sir? But they are designed to control current, and the current is only destroying them, sir. Like, this doesn't
Oh.
make any sense.
That is the
I
real
mean, they are
fact.
designed to control current, and the current is only destroying
They
them.
are
So,
controlling current through cutting the voltages, by cutting their voltages, right? So
yeah,
if the voltage is like this, they will actually cut the voltages, right? And in this sense, they will control the voltage, output voltage. The
yes,
current
sir.
value is decided by the resistance, the type of load. It is not decided by the type of waveform. The waveform
Yes,
of current and the magnitude of current will be completely dependent upon the type of load, right? Say for this type of thing, if you, this is the output voltage, right? And say this is the output voltage, and you are passing it through a short circuit, what will happen? The resistance tends to zero of a wire, right? So what will happen, tell me? A huge current will be flown, a huge current will try to flow. So this
yes,
is
sir.
this is the peak value of that thing. So this is, say, Vm equals to 325 volt for a normal 230 volt. So if it is having zero resistance, say, then what will happen? The current would be very high. If it is very high, the what, first of all, what will happen? The fuse will blow out. Say if it is a 5 ampere fuse, right? So 5 ampere fuse will blow out. If there is no fuse, the wires would get heated up, the device would actually break out. If the device is rated for 50 ampere current only, and you are trying to pass more than 100 amperes of current through it because of short circuit, what will happen? The
It will
device will
destroy.
get destroyed, right? So controlling the voltage doesn't mean you are controlling the current, right? You have designed that thing to control the voltage, right? What current will flow, that will depend upon the external resistor, is it not so? And
Yes,
if
sir.
you want to still avoid this fuse, you connect a MCB, you connect a MCB, that will trip out. Again, you
Mm,
have to go and just pick it up manually, right? So this is the thing. So did you get it?
yes, sir.
Yeah. So that was the function of dual converter. So here I have again highlighted it. Just a second. We have my pointers. So here you see, this is complementary angle. This pi means 180 degrees. So alpha 1 plus alpha 2 will be either equal to pi. See, pi means it will be in radians, right? So alpha and alpha 2 we have to take it in radians. If you're taking it in degrees, it will be 180 degrees. Simple, right? Okay, so single phase first quadrant AC to DC controlled. So this is all on the field control side. So this is now three phase. So three phase, you are sure of it? Three phase. Three phase. If you are having three phase half wave, what will happen? You will draw current from the three phases, and you will have a controlled DC output. So this will be again of three types. Second. So this will be three phase, three pulse AC to DC converter. Three pulse would mean what? Three pulse converter would mean what? It is half wave converter, right? And what about this? This is six pulse converter.
Full wave, full
This
wave.
full wave fully controlled converter. Fully controlled converter. Right? And this is what? This is also 6 pulse, but it is semi-controlled. Semi-controlled converter. Right? So what do you prefer? You prefer a so you prefer a single phase one or a 3-phase one? Tell me, what would be your preference?
3-phase.
Single phase or 3-phase? Those who want a single phase, write single phase in the chat box. Those who want a 3-phase, write 3-phase. So from the next class, I will take attendance in a separate sheet of paper, and whoever will be replying to the chats, they will only get the attendance. So please tell it to everyone. I will send a link at any point of time. Then only it will have it. Okay. So 3-phase. Why 3-phase, Purnandu? Why 3-phase? Sunil, why 3-phase?
More power, sir.
If you don't need more power, then if your power can be adjusted with a single phase only, then see, first of all, if you go for single phase, the output waveform will be at max like this, right? And if you go for 3-phase, simple one is it will be like this, right? Even if it is for 3 pulse or 6 pulse, if you go for 6 pulse, it will be like this, right? Maximum. So you know here the DC, here the output voltage is touching a natural 0. Is it not so? So if you want to have a flat DC, you have to fill up these gaps using capacitors and inductors. Is it not so?
Yes, sir.
But if you are using this, is it, first of all, it is not going to 0. So the gap that has to be filled up, using inductors and capacitors is very low.
Yes, sir.
Here also the gap is extremely low.
Yes, sir.
So say for this thing, you have to have a L and C, which is largest. And here it is bit less, and here it is the least. So if you are going for 6 pulse rectifier, then you have the least amount of L and C components that has to be connected. If you are going for 3 pulse, a bit more. If you are going for single phase, it's way bit higher. And if you are going for only half wave, then it is very, very high. Say for complete one cycle, you have to have the compensation. You have to store the energy and then throw it out again. Okay, so here it is the largest value of L and C, largest, right? And then this, and then this, and finally this. So this will 6 pulse will be the least. And also because if you are drawing power from a single phase, it will cause a disbalance in the other 2 phases. So better you take the 3 phases and take it on the 6 pulse one. That will have a balanced distribution of load in the 3 phases, as well as you will have to have a least amount of LNC. And if you have a least value of LNC, the amount of inrush current will also be less. Okay. So all these factors make the 3-phase much more better than the single phase. Yeah, however, if you could have a 24-phase, then it would have still been better, right? I think for today it is enough. We can continue it in the next class, right? Okay. So any doubts for this class?
this L and C thing, sir, why it is coming more in the single phase and half phase?
Okay. Just a second. Just a second. I will go to the chat. That is very interesting. Just wait a second. Say there are. So I need some volunteers, right? I need 4 volunteers, digital volunteers. Say there is a house where the water comes after every 1 week, right? There is a red house where the water comes after every 4 days. There is a brown house where the water comes after every 2 days. There is again a purple house where the water comes after every 24 hours or 1 day, right? Now tell me, for a constant load, say of 2 people each, and the 2 people have equal type of consumptions, tell me which one has to have the biggest, largest of buckets?
1 week.
Yes, so don't you think so? The bucket of this green bucket one, that is for the
Yes,
greenhouse.
sir. I mean, you are using a metaphor that like that bucket
Yes.
is
LNC.
LNC.
LNC, right? So this
Yes, sir.
bucket is actually the inductor and capacitor of the electrical engineering, right? So just Abhijit, did you get the similarity?
Yes.
So if you are having a half wave and you want to get a flat pulse, what do you expect for a DC to be? You want the DC waveform just to be like a battery, no? A battery can give out what? A simple straight pulse, a simple straight voltage. We want that replica only, no?
Yes.
Right. So for that, how much of compensation you have to store? It is this much high,
Yes, that would be very large.
right? And then for this, say this is for 2 pulse, the compensation would be
Less.
lesser. And for the 2 days, it is 3 pulse one, the compensation would be
Much lesser.
only this much. And just think about this one. How much will it be? It will be still less, very less.
Yes.
So that's the comparison. In electrical engineering, we have only 2 things which can store power instantaneously. That is only the L and C. Batteries, different batteries sort of, it will store power for a longer time, but for transient times, you have only the inductor and capacitor that can store energy. Okay, so these are the buckets of electrical
Sir,
engineering. Yes.
sir, in your 63 inverters or call it 63 pulses, even much lesser energy.
That
I mean,
is
the LNC
inverter.
required
That is
to store
inverter.
63
That is inverter.
which
That
will
is
even
inverter. That is not rectifier, right? That is not rectifier. We are talking of rectifier.
produces pulse, right? It will produce pulse. 6
Did,
pulse. Yes.
6 pulse is what? That waveform, output waveform actually, right? That comes out of the rectifier. What that is inverter, not a rectifier. Here we are talking about rectifiers. Why? We are dealing with DC motors, so we need a DC to run the DC motors, AC to DC, right?
Okay.
That's
Yes,
it.
sir.
So we will talk about it when we will talk about AC motors, right?
Okay.
So in AC motors, we need the inverters so as to run the AC motors. So for 3-phase AC motors, we will do that thing. Then, right now we are dealing with only DC. So Okay, so just let me show this thing. So this is what? This is armature control. So where the dual converter is used to have the control through armature voltage control, right? And here the field control is there. So field control can also be controlled by dual converter, but it is not generally used. So this is the same thing for the three phase also. The three phase dual converter is shown, and for the field control side, the same thing. This is the three phase DC drive. As you can see it, this is the half wave one. This is a three phase DC drive with all the equations, not necessary. Now in the next class we will start for the DC-DC chopper based drives, right? So this is used say in uh, driving the DC motors where the source is actually a DC voltage, not a AC voltage, right? Like a big battery, like HVDC lines, like any other type of solar sources is there. So there we use DC-DC chopper based drives. So we will be continuing with, I think most of all it is already that that 4-quadrant chopper and 2-quadrant chopper, class C chopper, all the things will be in this part, right? I hope I request you to all to have a revision of class C chopper and class that 4-quadrant chopper. In that way, you will be able to understand this section very easily. So can we continue it in the next class?
Yes, sir.
Yes, sir.
Okay, so see you in the next class. Thank you.